On the morning of April 22nd, 1992, a series of explosions rocked the streets of Guadalajara.
I told my family, get out of here. Something happened, I don't know what, but get out of here.
Starting just after 10 a.m. and lasting over 4 hours, at least 5 separate explosions devastated nearly 20 blocks of the city.
We don't know what happened in the city, just was the smoke, was the explosion, was all the fire, and a lot of people there.
News of the massive devastation traveled to Texas. And on the request of the Mexican consulate there, one Houston-based team was asked to visit the disaster site.
I put together a group of firefighters, some medical people, some people from Public Works. Our mission was to see what was needed and also to determine what caused the explosion if we could.
We figured we'll start at the outer perimeters where the devastation is and try to work ourselves to the epicenter. We walk around a corner and there's this giant ditch about 15 feet deep, in some areas even deeper. And it was just mind-boggling to walk out into that area and see the first 10 feet of the houses gone.
A jagged trench, exacting the path of the main sewer line, had devoured everything in its path, including cars, buses, and pedestrians. Adjacent homes and businesses were reduced to rubble. The scene resembled a war zone. By official counts, there were 215 dead, 1,600 buildings destroyed, and 1,500 people injured. The massive explosion had originated in the sewer main, buried underneath the city streets.
The explosion came through the pipe, came through the dirt, went straight up, and then all the debris came back down. It was something like I just never seen before. 40 years in the fire department, I'd seen a lot, never seen anything quite like that.
Most of the people conclude that there were about 3,000 deaths, but the official figures are around 200. They started to remove the debris 24 hours after the shock, so they had no way to separate bodies from debris.
Days before the catastrophe, residents in and around Sector Reforma, a working-class neighborhood located in southeastern Guadalajara, had lodged nearly 600 complaints of a strong gasoline odor emanating from the sewers.
There was alarm. There was phone calls to the fire department the night before because of the strong smell of gasoline. And there was a little investigation of what was going on, and everyone was told to go back to bed. And less than 12 hours later, it all blew up.
In the wake of the destruction, residents demanded answers to what went wrong and why the area had not been evacuated.
Government tried to find some answer to give to the people, but they created a couple of theories about the vegetable oil company, and there was no believable answer.
Despite what they were being told, it was obvious that the substance that caused the explosion was gasoline. And in Mexico, all of the gasoline comes from one source.
Pemex is the only oil producer in Mexico. It's a monopoly, and they produce and sell every liter of gasoline.
Somehow, large quantities of gasoline had seeped into the sewer line, creating a massive pipe bomb.
3 years earlier, the subway was built a few blocks away, and it had to cross where the main sewer goes. So they created a U-turn underneath the subway rails.
Much like a trap under a household sink, which causes a water plug that prevents sewer gases from entering the house. An airlock was formed in the sewer itself.
This gasoline is flowing through these sewer pipes underneath the city, and finally it reaches the right ignition point, the vapor density in the air, and possibly someone throws a lighted, like a cigarette butt that's burning out into a sewer, and boom, off goes the explosion. It sends out a pressure wave that pushes the rest of the vapors and the liquid gas farther down through the sewer system. Maybe it's too rich for a few seconds, and then it'll finally reach the right ignition point, and the burning gasoline then ignites the next section. It explodes, and it keeps moving and moving and moving.
The series of explosions did not go beyond the U-turn in the sewer pipe.
If there was no airlock, the explosion could have gone farther, or there could have been no explosion, but just a huge fire inside the sewer, but not an explosion because the heated air could have flown. There was no option because there was this U-turn, this airlock.
With the damage assessed and cause determined, the team from Houston just needed to locate the origin of the gasoline in the sewer.
We went back to the devastation area, and while we were there, the chief saw a pickup truck with workers that were going to leave, and he told the officials, said, why don't we catch that truck and just go with those guys, hoping that it would take us to this Pemex plant that we heard people talking about. So we jumped in the back of that pickup truck with the workers and went on to the Pemex plant. When we got out and started checking our equipment, that's when the hydrocarbon sniffers started going crazy, and it started saying that explosion was imminent. And the farther we went, the smell of the gasoline was just horrendous. And you look at the ground, and the ground looks wet, but it's not wet with water. The ground's wet with gasoline. The ground is completely permeated with gasoline that leaked up through the soil from the pipes that were underground. And then we definitely knew we had found where the leak was.
Right in front of the plant was where the pipe ran over the sewer line. And that pipe was leaking in the ground, and the ground was saturated. It was down at least 8 feet solid with gasoline. We saw them actually taking out the pipe that was rusted and leaking and trying to put in a new pipe.
The useful life of underground steel pipes, even when coated and wrapped, generally does not exceed 30 years without inspection, repair, or replacement.
The pipe was just really, really rusted and big holes in it. And the pipe they were going to replace it with wasn't that much better shape. They had whitewashed it, put some whitewash on it, and I don't know if that was going to be just temporary or just what that was about. We found the cause, we found the origin of the gas. We felt pretty good about accomplishing our mission and gave a report to the consulate.
With their mission accomplished, the team returned to Houston. In Guadalajara, a separate investigation was already underway.
The president of Mexico came here and he said, 3 days, 72 hours, and I want to know who is the responsible.
With a slightly different account than the Houston delegations, the Mexican government's inquiry concluded that an iron water main had been illegally installed, intersecting and establishing contact with the 12-inch steel pipeline. The dissimilar metal-to-metal contact in a moist environment caused corrosion to both lines. A half-inch hole was created in the gasoline pipeline, allowing an estimated 150,000 gallons of gasoline to leak into the soil.
And a little hole. And from this little hole flew or dumped all the thousand and thousand of liters of gasoline. This is the official version of all the investigation.
Upon completion of the investigation, the Mexican courts ruled that no one was at fault for the explosions, and the case was unequivocally closed.
The big question is, could it happen again? When you're in the middle of the situation, you don't care about who did what or play a blame game. What we want to do is find out, where's it coming from? Why did it happen? Is it going to happen again?
Pemex offered unofficially help in money, but they never accepted any of the responsibility of this explosion.
After we came back, we had no idea what happened after that, because it seemed like it dropped off into a black hole. Nobody really knew what was going on down there, or like it had never happened. But I just have this memory that I carry with me. I know what I saw. I know what I experienced. And it wasn't good.
Remnants of the destruction and memorials to the victims of the 22nd of April serve as constant reminders of this massive tragedy that unfortunately is little known outside the streets of Guadalajara. McDonnell Douglas's mighty DC-10, built to compete against rivals Lockheed L-1011 and the Boeing 747, was one of the workhorses of the world's commercial jet fleet for 20 years. But in the early 1970s, the new wide-body design of the DC-10 turned what could have been a survivable malfunction in a smaller plane into a deadly engineering problem. The cargo door could appear to be closed and latched, when in fact it was not. The Federal Aviation Administration determined that this unsafe condition resulted in one of the worst aviation disasters in history and began the negative public perception of the DC-10 that it would never escape.
The DC-10 really got a bad rap. I mean, it was the Corvair of the airplane industry.
The DC-10 was the Douglas Aircraft Company's first and only wide-bodied commercial airliner. The jet featured a spacious cabin design with 2 aisles and 3 rows of seats. But the air pressurization systems for the enormous cabin were similar to those used in smaller planes.
A lot of the design features of the wide-bodied aircraft were just scaled up from the previous narrow-bodied airplanes.
The DC-10 was a short-range jumbo jet, capable of carrying 343 passengers. It was less expensive than its rivals and soon became the nation's most popular wide-body aircraft. But in 1972, less than 2 years after its introduction, a DC-10 flying over Windsor, Canada, exhibited the first signs of problems in the new jet.
There was an incident involving a DC-10 departing Detroit. As it was climbing, the cargo door blew off and some cargo went out of the aircraft. The aircraft had considerable control difficulties because the loss of the door, depressurization had collapsed the floor in the back of the airplane.
As the cargo door came off, there was an explosive decompression of air in the cabin, escaping out of the hole. The pressure of the massive volume of air was so heavy that the cabin floor gave way. Even though control cables running under the cabin floor were damaged, the pilots were able to land the plane, and no life was lost. It was later determined that the vent door, a secondary locking device on the cargo door, wasn't secured before takeoff.
When we got the report from the baggage handler, he said he was having a hard time closing the vent door, so he had to put his knee on it to close the door, and he forced and bent the mechanism such that the light went off in the cockpit and the vent door closed. So the cargo door apparently looked like it was sealed, and the door itself was closed, but it wasn't properly latched.
The torque tube in the locking mechanism of the cargo door could be bent by human force. Once bent, the tube would allow the door to close, even though it was not properly latched.
The NTSB wrote a report and issued safety recommendations to the FAA, requesting that the FAA consider certain modifications to the door and to the aircraft to prevent the damage from a loss of the door.
The FAA allowed for the modifications to be carried out on a voluntary basis. Although most carriers repaired their aircraft, some, especially those operating outside the U.S., did not. On March 3, 1974, a Turkish Airways DC-10 departed from Paris. The first few minutes of the flight were routine. But suddenly, as the plane reached 13,000 feet, the cargo door blew out. The immense force of the pressurized air in the cabin as it rushed out the cargo door buckled the floor.
When the floor collapsed, some of the seats actually detached from the floor and went out the door, out the airplane.
Vital control lines for the plane ran just under the cabin floor. They were instantly severed.
What happened is that the airplane, because the floor collapsed and actually moved the controls mechanically, the crew cannot overcome that mechanical difference, so the airplane came down.
The plane slammed into trees in a forest. All 346 passengers were killed. Investigators soon discovered that the cause of the crash was almost identical to the accident in Windsor.
According to the French report, the door was not closed properly. That's why it came open. and they could not find evidence of the fixes that we had put out after the Windsor accident in the wreckage.
In both cases, the ground personnel forced the door or forced the handle, and because there was a bending and compliance in the push rods, the handle actually closed, therefore indicating that the cargo door was closed and latched.
After the Turkish Airways disaster, the FAA mandated that the cargo door on DC-10s operating in the U.S. be modified.
There were several design changes made to ensure that the operator of the door could not close the vent door unless the latches were in the proper position.
As a result of the Paris accident, there was a fix put on the door which included what they called a feedback loop. Not only was there a rod going from the handle to the latch pins and to the small pressurization door, there was a feedback loop. Another set of rods were connected back to the handle to show that the latch pins had in fact engaged properly.
The crash also resulted in a mandated design change for not just the DC-10, but all wide-body aircraft. These planes had small vents between the cabin floor and the cargo area, designed to equalize pressure between the two areas if needed. The venting system was adequate in smaller planes, but couldn't equalize the vast volume of air in a wide body.
That design feature worked well on the narrow-bodied older aircraft, and it was the same design used for the wide-bodied. However, the scaling up led to the problem that this tremendous volume of air, now in a wide-bodied airplane, those traditional vents were not sufficient. And that's why we had the collapse of the floor in the two DC-10s.
The fix entailed installing additional vents in the floor of the cabin, which would allow air to rapidly equalize.
If you have a pressure change, such as what would occur as a result of such as a cargo door opening up, then these doors would open up. They're kind of spring-loaded and they basically open up. And what they do is they allow then the pressure to vent around the outside of the floor, and it keeps that whole floor from collapsing.
A series of unrelated accidents involving DC-10s, including the 1979 crash of Flight 191 in Chicago, which resulted in the grounding of all DC-10s, culminated with passengers refusing to fly on the aircraft. Orders for the plane slowed, and in 1989, the DC-10 went out of production. However, the existing 446 planes continued to operate around the globe.
It is definitely a safe airplane. In fact, because of these accidents that it had, it was not only certified once after the Chicago accident, there was an investigation of the accident, and there was an investigation of the design of the airplane. So it was really certified twice. It had to be the safest airplane after all of it went through of all time.
Despite this troubled beginning, the DC-10 ultimately proved a reliable aircraft, and the safety record improved as the fleet hours increased. In fact, the DC-10's lifetime safety record as of 2003 surpassed that of the venerable Boeing 747. Nevertheless, the remaining DC-10s operating in the United States, once an icon of luxury travel, have been relegated to cargo duty. At 12:22 p.m. on July 19, 1985, two mining dams burst in Stava, Italy.
It was impossible to believe what we saw. How two banks of sand could become two atomic bombs that caused the total destruction of the Stava Valley.
The rupture unleashed a mud and sludge wave more than 100 feet wide. It flowed at a speed of 55 miles per hour.
It burst out, and of course, considering also the natural slope of this valley, which is quite steep, it gained progressive momentum. It reached a very high acceleration in a matter of seconds.
The mudslide was over in 4 minutes, but during that time, 268 people died, and 4 hotels and 50 homes were flattened.
I saw that everything was swallowed up. There wasn't anything left, not houses, not anything.
The town of Stava was virtually wiped off the map. The event has been called one of the worst industrial catastrophes in the world. But it could have been prevented. Stava is located in northeastern Italy, nestled in a picturesque alpine valley. Though it's primarily a farming community, Stava has mountains rich in fluorite, and in 1934, a very productive mining industry began. In 1967, the first tailings dam was started. The tailings dam's purpose was to contain the waste material from the mine. The waste was a mixture of silt, sand, and water. The sand formed the dam structure, and the silt and water were stored in the basin itself.
So their purpose is to store material at the fluid state first that couldn't be discharged directly into watercourses because they've got a high pollutant content.
The silt was supposed to sink to the bottom of the basin and solidify, while the clear water was recycled into the streams and rivers of Stava. As more material was poured into the dam, the size of the basin increased. In just a few years, the tailings dam rose to 65 feet, twice the normal height for this kind of structure. In 1969, the mine owners decided to start another dam, right above the first one.
The choice couldn't have been worse because, first of all, we are on a steep slope that these structures can be considered completely stable only if they are built in the proper manner on flat ground, which of course was not the case here.
Another factor that led to the disaster was the nature of the soil on which the dams were built. The marshy ground in Stava was not firm enough to hold the large earthen structures.
Just walking along the slope, you see that the ground is soggy, it gives way, it's always saturated with water, and you can actually see springs coming out from the ground.
Over the next 6 years, the two tailings dams grew to more than 165 feet. Local residents became alarmed, and in 1975, they called upon city authorities to inspect the dams and determine their stability.
The thing was done by an engineer that was appointed by the company itself that ran the mine. So, of course, his judgment couldn't really be considered objective. This man, when he saw this structure, he says, it's a miracle that they haven't already collapsed.
The engineer suggested that a test be done to determine the firmness of the soil. The test would have cost approximately $13,000.
And the direction of the mine said, that is too much money just for this. We'll do it in a more simple way. That is getting an iron bar and pushing it through the soil and test like this manually if the soil was more or less firm. Of course, a test like this is ridiculous.
In fact, because of the marshy nature of the soil, the silt in the basins had not drained properly, becoming heavier and putting more pressure on the outer structure of the upper basin. On July 19, 1985, the upper dam suddenly collapsed down into the lower basin, which burst with an earth-shaking force.
I saw the masses of sludge crashing down. From there, I went into a state of mental shock.
My house wasn't there. I went just about out of my mind. My family was made up of my wife, so dear to me, 3 daughters and 4 sons. I was left with 2 daughters and a son.
Rescue efforts continued for weeks after the Stava disaster, but very few victims were found alive.
You couldn't go and help anybody because there was so much mud, it was like being in a bowl of pudding. If you saw arms, legs coming out of it, there was no way for you to get there to rescue these people. I remember that the first person I rescued was a child, who I remember to this day.
In the official court proceedings, 10 people involved in the construction, management, and monitoring of the upper basin were found guilty of causing the disaster through negligence and incompetence. They were also convicted of multiple manslaughter charges. Previous owners and engineers were never arrested.
Come si possono chiamare?
I don't know what you call it in America. Indulgences, leniency.
Dei perdoni.
And they benefited from such leniency.
The court-imposed fine exceeded $131 million, well over the $13,000 expense that might have prevented this disaster 10 years before.
So, greed, negligence, superficiality, speculation were the main aspects of behavior of the people that caused this disaster.
Too many people think business is more important than life.
The Italian parliament also introduced a new law to make the construction and maintenance of tailings dams safer. The entire country mourned the horrifying loss of the people of Stava. Pope John Paul II paid a moving visit to the memorial site in 1998. In February 2002, several of the victims' families established the Stava 1985 Foundation.
Essentially, so that the 268 people who died didn't die in vain.
The town of Stava is now rebuilt, coming back to life after the disaster. It is a living, growing monument to those who were sacrificed by its destruction in 1985, and a lasting reminder of the resilience and spirit of those who survived. Natural gas is colorless, odorless, and tasteless. The familiar rotten egg smell we associate with gas is actually mercaptan. It's added before distribution, giving natural gas a distinct odor that serves as a safety device, allowing it to be detected when a leak occurs. Research to find an effective odorant began as early as the 1920s. However, it took one of the most heart-wrenching tragedies in American history, the deaths of over 300 school children, to necessitate the use of a malodorous additive. By the early 1930s, the Great Depression meant economic disaster for the entire United States. But East Texas fared better.
Dad Joyner came to East Texas and he discovered this oil. And of course that changed the world of East Texas and this community forever. And this was the bright spot of the whole United States at that time.
Like many oil boom towns, New London, Texas, just 130 miles east of Dallas, grew from approximately 850 to several thousand overnight.
There were so many people moving in here with kids that the little two-room country school was too small. A modern school was built at a price of $300,000. At the time it was built, it was one of the richest school districts in the world.
The state-of-the-art school sat on a 15-acre campus and had 10 oil wells located on its grounds.
That was another exciting time of my life, moving from a three-room schoolhouse where we had multiple grades in one room, moving to a large two-story brick school that had housed a high school, junior high, with all the facilities that any school in the country had.
The school administration decided to save $300 a month on heating fuel by using natural gas. At the time, natural gas was a worthless byproduct of petroleum extraction.
Everybody got free gas from the oil companies. They had so much gas that they had to burn torches at night.
A connection was made to the company's pipeline, and the free gas was fed directly into the existing pipelines in the school's sub-basement. But their connection leaked, and by March 18, 1937, nearly 6,000 cubic feet of gas had slowly collected in the school's poorly ventilated sub-basement. With no way of detecting the leak, the school day continued as usual, with a ticking time bomb just under the feet of London's students and teachers.
Everything was normal until about 3:18 that afternoon. That was the last period of the day, and my last class was English class. At the beginning of the class, I asked a girlfriend that sat in front of me to change seats with me. I wanted to sit behind the little girl that sat in front of her. She graciously traded seats with me.
Just minutes before the school was to be dismissed, the shop teacher plugged in a sander, and their esteemed school exploded.
I didn't hear anything, nothing, no sound at all. It must have been a horrible sound because I lost the hearing in my right ear. The ceiling fell in, and I don't know where it came from. Anyhow, that was all on top of me, and I had my face down against my desk, and this material was on top, and I couldn't move. And I heard some of the boys talking, and one of them said, there's somebody under here. And I said, I am. Get me out of here. So they lifted it up and helped me out.
The impact of the combustion explosion had lifted the building into the air, and it slammed back into the ground, entombing students and teachers in its brick, steel, and concrete.
And I looked at the building. In front of the building was completely gone. It had blown up and just fell right back down on the ground flat.
The devastating explosion was heard nearly 4 miles away. Within 15 minutes, the news had been relayed over telephone and Western Union lines. Frantic parents rushed to the school. Residents and oil field workers brought in heavy equipment.
People was just coming from everywhere. They just started hollering and screaming. People everywhere just couldn't find their children. They carried them everywhere. They had to start making makeshift hospitals.
Legions of volunteers and parents frantically dug through the night, looking for the young victims.
Within 17 hours, it was cleaned up. They cleaned it up so fast that it hindered the investigation. By the time they got people in here to investigate what happened, there was nothing to look at.
The grief of the tragedy was widespread. Condolences came from all over the world, including a telegram from Eleanor Roosevelt, as well as one from the Chancellor of Germany, Adolf Hitler.
We returned to school 10 days later. Some of us, a lot of us wasn't there. They called a roll in the old gymnasium and gathered by grades, and there's probably 50% of the normal capacity of the classes there or less. And that's when I discovered that the girl I traded seats with was killed. And like I say, that I carried that guilt with me.
Of the estimated 650 students and teachers in the building, 319 were dead.
There were 3 investigating agencies came in, the State Board of Inquiry, the Bureau of Mines, and Agricultural Department. They all reached the same conclusion that no one is to be held liable for the school explosion. Since natural gas at that time had no odor, it would not have mattered how they were getting it or how they were using it. It would still happen.
3 days after the explosion, Texas legislature called a special session in order to pass the authorization law that we smell gas today for our safety and protection.
The Texas regulation was quickly adopted worldwide. But tragically, it took the lives of nearly an entire generation in one small town to bring about this momentous leap forward in safety. Since the inception of the oil tanker, many accidents have garnered horrific headlines. In the 1990s, there was on average more than 1 oil tanker spill every 2 weeks. But it was the catastrophic grounding of the Torrey Canyon oil tanker in 1967 that introduced the world to the devastation of the super spill. On March 18, 1967, the Torrey Canyon ran aground off the southern coast of England. Within 2 weeks, her entire cargo of 119,000 tons of crude oil was lost. Close to 200 miles of pristine coastline were defiled.
This was a really big spill, even by modern standards. The tanker spilled 3 times the oil that the Exxon Valdez spilled in Alaska, and we know what damage that spill caused.
Nearly 4 decades later, the Torrey Canyon accident serves as a valuable lesson of how poorly designed instruments can be the catalyst for human error on a grand scale. In 1959, when the Torrey Canyon was first put into operation, she had a cargo capacity of 60,000 tons of oil, considered small in an era when many ships had a capacity of over 100,000 tons.
In the late 60s, our dependence on oil, the consumption of oil worldwide was growing astronomically. Oil was about 30 cents a gallon in the US, and cars got 10 miles to the gallon. So we were using more and more oil globally. Consequently, the rise of the supertanker, the transportation of oil, started to take on new dimensions.
In 1964, as oil demand increased, the owners of the Torrey Canyon decided she would be more profitable with an even larger capacity.
In 1965, Torrey Canyon was brought to the Sasebo Shipbuilding Company in Japan for jumboization. Jumboization, in the case of the Torrey Canyon, as well as many other tankers, involved cutting it at midships, separating the two halves, and then inserting a large section in between with additional cargo tanks.
When the Torrey Canyon went back to work in 1965, she was the 13th largest vessel in the world, capable of carrying close to 122,000 tons of oil. The ship was also equipped with an autopilot feature.
Well over 90% of the time on the Torrey Canyon, as well as similar ships like it at the time, they were on autopilot. And the autopilot system allowed the helmsman to set a compass heading, such as 18 degrees, and it would just hold that compass heading.
Several days before the fateful collision, the autopilot was set to 18 degrees north, sending the Torrey Canyon well clear of the Scilly Isles, a chain of rocky islands which stood between the ship and her final destination, a port on the west coast of England. The captain had the ship running at full speed, 17 knots, in an effort to beat a narrow tidal window on the evening of March 18th, when high tides would make the port deep enough for the ship to enter.
If he missed it, they would have to wait 6 days, and the costs for the crew and the ship and reserving the space in the harbor were substantial. So he was under considerable time stress to make this date.
Before he turned in on what would be his last night afloat, the captain left orders to be called when the islands were detected on the radar, signifying their final approach to port. Early the next morning, radar revealed that strong currents had unexpectedly pushed the ship to the east. The Torrey Canyon was aiming right for a precarious channel between the islands and the coast.
When he found that he was not where he thought he would be, off the Scilly Isles, his normal course would have been to steer all the way around to seaward of the Isles and come to port.
Going around the Isles would add several hours to the journey, likely causing the tanker to miss high tide at the port.
The captain decided that he would basically shoot the gap, about a 6-mile gap, between the Scilly Islands and the 7 Stone Shoals. It was a tricky maneuver and not something most any supertanker captain should seriously consider doing.
But after entering the channel, the captain realized the autopilot had the tanker on a collision course, with submerged shoals surrounding the islands. He shifted to manual steering and spun the wheel to the left, believing he was turning the ship away from the rocks. The fate of the ship was about to be sealed by a seemingly minor design flaw.
The captain and the other officers went back to the chart room, thinking that they had just avoided a catastrophe, when he heard the helmsman screaming for him, saying that the ship was not responding. The ship was not responding because he had accidentally, unintentionally pushed the control into the control mode, which disengaged the helm. The steering wheel was ineffective.
After realizing the error, the captain moved the selector to manual steering.
By then, it was far too late, and the Torrey Canyon ground to a halt over Pollard Rock, part of the 7 Stone Shoals, and was ripped wide open.
The captain's inability to steer the ship out of harm's way was later attributed in part to the design of the autopilot mechanism, which slid easily and without warning from one gear to the next.
The control position on the 3-position lever was similar to neutral on a car. But unlike a car transmission system in which you go, say, from park to drive and you have to press a button or input, make a separate action to make that change, you could just shift this control to any of these 3 positions just by simply moving it intentionally or unintentionally.
Within 72 hours of the collision, an estimated 37 million gallons of the tanker's cargo leaked out.
The ship was gently creaking, and the oil was all around the ship from the wherever she was ruptured in the hull.
The tanker was so firmly impaled on the rocks that no tug could pull her off. Efforts to clean up the massive oil spill were futile.
They went at this from every angle. They hit it with napalm. They tried to burn the oil away. They hit it with explosives, trying to sink it. That didn't work. Then they hit it with tens of thousands of tons of detergent to try to soak the oil or disperse the oil. And that didn't help at all. In fact, that proved more toxic to the ecosystem. There was no precedent for this type of crash.
Within a few years, more effective cleanup methods became common practice. But amazingly, a better autopilot design was not installed on oil tankers until over 20 years later.
You had the same problem, it appears, on the Exxon Valdez with the autopilot engaged. They turned the wheel, but the vessel did not respond because it wasn't supposed to. After Exxon Valdez, they made a change so that if you turn the wheel while it is engaged, an alarm sounds.
Navigational technology on oil tankers has been greatly improved since the Torrey Canyon.
Nowadays, you can have alarms if you get off course, audible alarms, basically anything you want as far as the navigational aids. The GPS knows where the ship is on the surface of the Earth, and the rudder will be changed to keep the ship on the prescribed track that the master laid into the computer.
The ever-increasing number of automated features on modern tankers are most successful when designed with the user in mind.
Particularly today, when systems are becoming so very, very reliable and well-engineered, it is the user interface and the human factors that play the greatest role in the success or failure or reliability of major systems.
Another lasting consequence of the ecological calamity was that the accident made the international community realize the need for stricter penalties for oil polluters. International policies were put into place to provide relief to the victims, and by 1969, ship owners became strictly liable for their spills.